Good afternoon, all. I think the presentation is visible and my voice is audible. So I hope that any of you please send me the status that you are capable of observing the slides and the voice you capable of hearing. Please, any of you, please ping me. Okay. Any of you can ping me in WhatsApp. I will start the session by 2. I will start the session by 2, okay? Just wait for 2 minutes. I will start the session by 2. I'm just waiting for others to join the session and I will start by 2. Then I can address the topics which will be covered today. I'm just waiting for others to join. Please bear with the delay, okay? The voice and the slide presentation, whether it is visible and audible, please any of you can ping me. And always I will try to make the session interactive. You can always send me the WhatsApp if you have any query regarding the session also. Just wait. So already it's 2 o'clock. I have just watching only 6 people are there. So let the other class get ended and let others join the session. And this lab is a 2-hour lab, so you know that one. So the time duration is quite long. So we will be doing the experiments and all these things, okay? So good afternoon all my dear students who are present here, and I welcome you all to the second week of the DLD lab, okay? I hope the presentation is visible and the audio is clear to you all, and I think there is no discrepancy in between, okay? Now first of all, I request you all to do all the classes, okay? You can think of the teachers will say the same thing every day when she will be coming and telling the things, because this is for your benefit, okay? Actually the people who used to do the classes, they mainly listen all those things, so it's not like that. And the people who do not come to the classes, maybe they are feeling some problem, that's why they are not attending the classes. They can ping us what can be the problems. Actually I have jotted down few problems they are facing, so I will try to resolve all those things one by another, okay? So it's my earnest request to all of you to please try to attend the classes, okay? Because this is the second year, you know. Now Just wait for 1 to 2 minutes. Many of you are just pinging. Just wait 2 minutes. I will just wait because I do not know what is the reason. I'm just waiting for 1 minute. Others are just joining. They are just pinging me. Okay. So many of you have texted me regarding the problem of installation of Proteus. Okay, that is the valid problem, because if you see the system that each of you are having, maybe they are of different systems, right? And due to that only some of you are capable of installing that one properly, and some of you are unable to install it. So no need to worry at all. This is only 1 week. I will definitely tell some alternate methods how to solve this problem. There are other softwares. That are also available. LT Spice is a software. I think those who have done the labs, those who are joining now, I am just welcoming you all because I am just watching that you people are a bit late. No problem. We will just continuing with the session. I am just emphasizing on that those people who are having problem in the installation of the Proteus, they can take any other alternate method like Tinkercad or LT Spice. Please have a pen and paper with you. I request all of you to have a pen and paper with you. You know that whatever the solution I do, I used to have this hands on, right? So please have a pen and paper with you. So we will be just doing the theoretical analysis, then we will be implementing all these things. So I request all of you to have a pen and paper with you. Okay, we will be doing slowly, no need to hurry up because you have 2 hours of time. We will be doing all these things. Okay. Second thing I like to tell you about the Google form link fill up. Okay, in the last week what happened, many of you are unable to fill up the link, and then you texted me that ma'am, I am unable to fill up the link. Okay, so I request you all to fill up the link by 4 because there are some reason we need to fill it up, okay, within the stipulated time. We need to send the data also. Okay, so what happened, and this is my error also, that I have given too much of assignments in the last class. Okay, that was my fault also. So I have not predicted that you people are only the second year students, so you are not too much matured. Fine. So I think today I have not given too much of assignment. We will be doing whatever you will be doing. You just note it down, and I am just telling you the assignment what is there. You please try to solve it in the copy. Those who are not having the Proteus software, I request you can solve this one in the normal page, and you can then scan and upload that one. Okay, so I request you all, those who are having Proteus, please try to solve this one, and the problem statement, please note it down. I have just given a simple problem, that implement and or please write it down. Please implement and or not using NAND. Okay, very simple problem I have given, and we will be doing this in this session also. So no need to worry at all that ma'am is doing and we are not getting the time. It's not like that. Okay, so if you are not capable of doing that, at least 1 or 2 questions or 2 implementation also at least you do, and you send it within 4. Okay, that is my request. So I request all of you to send the Google form, fill up the Google form by 4 only. Okay, and not too much of detailed problem I have given. I have given only the basic problem. Please note it down. Implementation of and or not, maybe ZOR is there. If you are not capable, please don't do it. Please don't do it. যতটুকু পারবি ততটুকু করবে. The portion, the thing is that how much you are capable, please try to solve it by your own. That is the requirement. Okay, We know we teach you too much and you people are lagging behind. That is not our purpose. Our purpose is to let you learn at least 5 to 10%, that you learn by your choice. Not, I am not forcing you to do it. Okay, anyways, that is the thing. Okay, another thing is that regarding the submission of the assignment, many of you have asked me, okay, many of you have texted me that, ma'am, how can we submit the assignments? Because there are different types of assignments I am giving you. One experiment wise I will send you a list, okay, what are the assignments, because this week will be the second week, right? So the previous week I have given implementation of basic gates using the NAND and NOR. Implementation of basic gates using the Proteus. That is the first experiment I have given, and this week I will be giving you the how to implement, and all these things I will be coming. Okay, just wait. So I am just by this week or by this maybe Friday, I will create Google Classroom for each of the 10 sections. Okay, I do not know whether you have CR or not. Okay, thank you Priyanka for sending me the feedback that it's audible and visible. Thank you Priyanka. So so every time when some assignments will be given, so you have to submit that one in the Google Classroom. I will give you the link. Okay, I will give you the link, and the class codes will be provided to you, and no need to rush. By this weekend you need to just do it. Again I am telling you, those who are not having Proteus, no need to worry at all. Just write down any A4 sheet, write down the question and the corresponding answer, and you will get the full marks out of that assignment part. Okay, no need to worry at all. Okay, now just come to the lecture part now. Okay, so we will be starting with experiment number 2. Okay, now in experiment number 2, what we are supposed to have, this basic gates not and or we will, and XOR is also there. This is not the basic gate, this is another special type of gate. We will be implementing these 4 gates using the 2 universal gates. Okay, you know the IC numbers of this. 4011 is the IC number of NAND gate, and 4001 is the IC number of NOR gate. Okay, is it clear to you? I think I will be coming to the slides also, because some prerequisite is required, because if we people generally do not remember everything what happened in the last class. Okay, and this is the part 1, I can say this is a part 1. And another thing, it is my earnest request to all of you that I prefer to write in this way. Okay, I just have seen the Amazon and the pen tablet I have searched for, but due to the lockdown and all these things, it is showing it's not available. Okay, so anyways I will try to write in this fashion, because for me it is very difficult to read out the slides. Okay, so this is my mode of teaching, you can say. If you do not like that one, you can just send me a text, ma'am please change the mode of teaching, I will change it. Okay, so it's up to you, because we are doing for you only. So if you do not like this, I will not entertain this mode of teaching, that every time I will take a red pen and the red dot and I will just scan all these things. So these 2 experiments we are going to do today. Okay, now it seems like it is very easy, but you will see it will take time. So have patience, please open the Proteus also. Those who are having Proteus, please open the Proteus also. Those who are not having the Proteus, please have a pen and paper with you, so that when I will be showing you the slides, please note the circuit, so that in the assignment part at least you can take the snapshot and you can send it in the Google form. Is it clear to you? Now the IC, you know, this is 4011. In the last class, in the last slide also I have given, I require these 2 numbers. 4011 is the NAND gate IC, and you know that not of AND is NAND, right? So when you have 1 1, then only the output is 0. Otherwise for the first 3 cases the output will become 1. I think it is known to you. I will not drag the same thing. Okay, I am just coming to the next slide. Okay, now this is the second one, NOR IC number 4001, and this is the truth table of the NOR gate. Okay, truth table means 1. In case of OR gate, if any of the input is 1, the output is 1. Okay, but in case of in case of normal OR gate, what will happen if both the things are 0, then the OR output will be 0 and the complement of that will be 1. So the rest 3 cases, the ones are there. Here one is there, another one is there, both the cases ones are there. So in those cases definitely the OR output is 1, right? So for this case, for this combination the OR is 1, then not of OR will give you 0. So this is the way we actually do it, right? Now see this one. Why I have given the slide? Because I require the slide. Okay, in the last class Monday Nilanjan sir has taken your class, right? So there he has told you different types of laws. Okay, why these laws are required? These laws are basically required to solve the Boolean expressions. Okay, to solve the Boolean expression. Now your question may be, why ma'am we need to solve the Boolean expression? What is the requirement of solution? Because we want the circuit size to be in a miniature form. We want the circuit size in a miniature form. That's why if you have a big expression, we will try to solve that one in a smaller expression, and normal Boolean laws, we will having Boolean laws, and we can use Boolean laws to solve this one, as well as we can also use K-map. In later classes I will tell you, or in NB sir will tell you that how to use the K-map to reduce the expressions. Okay, now mainly I will be using, because I require this to, please note it down, De Morgan's law, you know this one, please note it down, this too. Now my method of teaching is what I used to tell in this way. You have this bar, when you are applying De Morgan's law, the bar is broken. So you can tell me that why ma'am you are telling like this, bar is broken. So this bar is broken into 2 pieces, and the intermediate sign, you know that plus and dot, there will be 2 signs, right? So the plus will be converted into dot and the dot will be converted into plus. So this is the way actually I explain. This is my mode of teaching. Those who have joined recently, I am just welcoming you all during the session, and I like to tell you one thing. Those who are having the Proteus software, please no need to worry, they can continue with that, and those who are not having the Proteus software, I request all of you to note the circuits in a white page. You note it in pen and paper, so that at least for the Google form submission you can submit the assignment. And my assignment that I have told you earlier, that implementation of AND or NOT all the basic gates, as well as OR also, using the NAND, only the NAND. I will be describing here NAND, NOR and another function, but I do not require all these things. I will be taking the assignments again through the Google Classroom. Okay, now these are 2 special types of laws. These are also very much useful as far as the Boolean solution is concerned. Okay, now this I am just dividing the section into 2 parts. The left one, you know, this is the simple NOT gate. Now my intention is what I am just telling you very clearly. Okay, my intention is what, how this from A, if A is the input of this section, I think all of you know this, still I am just repeating. If you are giving A to this section, how you are getting the output. Okay, now if A is going to be as the input, it will go to both the input pins, right, of the NAND gate. Maybe 1, 2 are the 2 input pin and 3 is the output pin. Okay, now in this case what will happen, A is going to be there, so I can write down A is one input and another input you have this A, right? So whatever is A into A whole bar will be the output of this. And in the previous slide also you can see that A into A is A plus A is also A and A into A. So here A is coming and here also A is coming, right? So A into A will give you A bar. So this is the way you are getting the output. So if you are giving 1, you are supposed to get 0. If you are giving 0, you are supposed to get 1. Okay. This is my and that is the output we are getting as the output section of the shorted NAND gate. Okay. This is the term also, you please write it down. Every time I will tell you shorted NAND gate. What do you mean by shorted NAND gate? NOT can be improvised as the shorted NAND gate or shorted NOR gate. Okay. So if you have any doubt, you can just ping me in WhatsApp. I hope till now you do not have any doubt. Okay. And the thing is that please note this circuit. I'm just keeping this one for a second. Please note the circuit. Shorted NAND is working as NOT gate. Now come to the next gate that we are going to implement. Our aim is to implement OR gate using the NAND gate. Okay. Now if you have this one, so A you are giving as the input. I think if you are facing any problem of understanding the way I am writing, I am sorry for that. And B is another gate you are giving as the input. Now you tell me this shorted NAND gate will work as what? It will work as NOT gate, right? So what is the sectional output you are supposed to get here? You are supposed to get here A bar, right? You are supposed to get here A bar. I will come to the Proteus section. Please wait for a while. Just let me complete the theoretical section. I will come to the Proteus also. Okay. And I will do the hands-on the way I have shown you in the last class. Now similarly, this is also another shorted NAND, right? So the sectional output at this section, what you are supposed to get? You are supposed to get B bar. Now what is the output, final output? Can I write here? The output, we can say whatever the two inputs A bar and B bar, that will go to the NAND gate. And I think all of you know this one, just I am brushing up a bit. So A bar will be one input, B bar is another input, and you are just doing the NAND operation over this, right? So can you tell me why I have shown the previous Boolean laws slide? Now you will realize. Now which law I have to improvise here? I will improvise the De Morgan's law. Okay. So in case of De Morgan's law, you can see that I will be breaking the bars. That means this bar will be divided. So what can I say? The breaking the bar means A bar is there, right? Fine. So another bar will be there because the bar has been broken, right? Now this plus is converted into, dot is converted into plus. Okay. And then B, we have another thing like B bar bar, right? I think this is clear to you. Now if you just write, please bear with my handwriting. It is not very clear because I do not have the pen tab with me at this point of time. I am trying my level best to let you understand. Still, if you are facing any problem, I will just have the normal slide presentation because that will be easier. But I prefer this mode of teaching because you will see and you can do it in your copy also. Otherwise I should have given, because I will give everything in the official group, but and I think that all of you have been shifted from the WhatsApp to official Telegram group, right? So anyways, so this A bar bar will be what? A bar bar is nothing but not of not. Not of not is what? আমি বাড়ি যাব না I do not want to go home, and not of that is I want to go home. So not of that of a sentence bit, the sentence. Okay, that means A itself, and here B. So which type of operation it implies? It implies OR operation. Okay, now can we write the simple? So for the last three cases, for each of the combination you have 1, that's why the output I am writing as 1, and for the first cases both the inputs are 0, so I am just keeping the output as 0. Okay, those who are not having the Proteus, I am repeating once again, please at least the NAND part you write it down from the very beginning in the copy, so that today's assignment at least you can submit by scanning the thing, okay, in the Google form. I will open the link by 3:15. Okay, so you have 45 minutes of time, then I will continue the thing. Okay, but at least the scanning and uploading part you can do meanwhile. Okay, 45 minutes of time, but do not tell me, ma'am, please open the link after 4. Okay, now this one, and using NAND, I think all of you can do it by yourself. So this is the first NAND gate. So what is the sectional output? The sectional output will be x dot y is a product and not of that. So x dot y bar will be the output of this section. And what is this? Whatever is this is a NOT gate, right? You can see this is a shorted NAND is NOT gate. So whatever is the input, what is the input coming here? This is x dot y whole bar is the input coming here. Not of that will be the output. So x dot y is bar will be the input that is coming here, and not of that will give you the output, right? So this will give you basically x dot y. So bear with my handwriting. Okay, I request you all to try to understand the thing. I think you people are enough intelligent to, and you have studied enough thing, because this 2019 batch is a very good batch, the teachers have told you. Okay, so you people are bright enough, right? So you can understand that. So product means what? If one of the input is 1, the output will become if the input is 0, the output will become 0, right? So for the first 3 cases you have the inputs, so we can write 0 0 0, and for the last one you can write 1. I think it is clear to you. Okay, now let's come with the complicated one. The complicated one we cannot because in one slide, so I should have shown all these things, but I have just show what is the inner meaning of this. It will come like a bar b plus ab bar. From where it is coming I will show you. Okay, now the circuit for XOR gate using NAND is this. So what in the assignment, today's Google form assignment, what are the 4 circuits you have to do? Just in white page you write down the circuit of this, the shorted NAND that implies the NOT, this OR gate, this is this circuit, then this circuit, and last one will be this circuit. Okay, okay, so I will be telling you all these things. We have to do it using the Proteus. Someone texted me that without Proteus how will you do? So you prefer to have the Tinkercad, Tinkercad. Tinkercad is the software you can implement, and that is online available. At least meanwhile, those who are not having Proteus, not for today, for next coming week, even if you are unable to install, try to implement those things. Those who have installed Proteus, no problem for them. Okay, those who have not installed Proteus, please try to implement the circuits using the Tinkercad or LT Spice. I think the question, I do not know your name. You have pinged me previously also, but I am unable to solve your problem. That's why you can shift your domain, right? Shift the platform of doing the simulation. Okay, that I can say. Otherwise it is very difficult from my end to understand. Okay, so just let's have the equation output, and I think after I will take 2 minutes to go to the Proteus part. Now, so first 4 circuits which I have shown you, I will just implement it in Proteus first, then I will come to the NOR based circuits. Okay, now see this one, A is coming here also. This is the A version that is coming here, and this A bar plus B bar, this is coming in this probe, right? So what is happening, you are getting this one, and if you use the De Morgan's law, and you can just multiply a into a bar will be 0, so a b bar whole bar. So actually a b bar whole bar, if you apply, you will get this, right? You will get this. Okay, now what is the function you have to do it? The function is that the function we are going to, similarly if you give like this, you will get a plus b bar here. Now we want to do the solution from a bar plus b and a plus b bar. How we are getting this a bar b plus a b bar? Now this two input, this is one input and this is another input, and we are sending these two inputs. Okay, I will be repeating the NOR part also, please wait. Okay, I will be telling the NOR part also. Okay, so this function we can say, what is the one input that is coming here is a bar plus b. You can do it by yourself. Okay, and another input is there, a plus b bar. Okay, another input is a plus b bar. Okay, so this one you can see, and not is there, right? So you have the bubble here, so this the whole bar is there. Okay, so is it clear to you? I think all of you have done this one. Okay, now what we have to do, so you have the product here, so can we break the bar? We can break the bar. Okay, so if you break the bar, what can I say here? I'm just writing in brackets, so it will be just whatever was the thing, a bar plus b. Okay, just wait, and then plus will be dot will be converted into plus, right? This will be converted, then within bracket we can write a plus b bar, and another part of the bar is there. Okay, now in this case what we can find, so those who are joining now, I am telling you that our experiment is basically we need to implement the 4 circuits using NAND gate, that is the AND, OR, XOR, okay, and NOT. 4 things we are going to implement using the NAND gate as well as NOR gate. Okay, NOR gate part I will be repeating. Some of you just texted me that how to the NOR is working, so I will be coming to this part. Just wait for 2 minutes. NOR part is there in today's lecture, but no assignment is given. Okay, so there is no assignment for this part. Okay, now if you just do this one, you will be getting as a double bar. Okay, so a double bar will be the sectional output, and this plus is going to be converted into, and you write down b bar. Okay, and this is plus, and this a will have the bar and it will be converted into dot, and you have the b double bar. So what is the ultimate function now? You will, a double bar is a, then you have dot b bar plus a bar dot b double bar is b. So this is the full expression of the XOR gate. So basically this XOR implies this expression, a bar a b bar plus a bar b. This is the expression of XOR gate. So we will implement this one also. Now, so this is the implementation that I have done in the Proteus. So we can do it also today. Okay, someone has texted me that can you explain this? I think your equation you have not seen. The equation you see a into a bar b bar, and this is happening. So what, before using De Morgan's law, please mention your name. Okay, otherwise it is very difficult to explain. So this a into a bar is what? 0 plus a into b bar, so a into b bar and whole bar is there, right? So from there, if you just use the De Morgan's law, can you implement, right? A bar, the dot will be converted into plus, and then b double bar will be b. I think, is it clear to you, right? The word file assignment you have to give in the classroom, Google Classroom. Okay, I will send you the format where you have to submit. Now this is the way we can implement this one. So this first, in the same panel we have implemented this symbolizes the NOT. Okay, this is the NOT gate we have simply mentioned. Next, this is basically the AND gate we have implemented, and this is basically the OR gate. Okay, I think this is clear to you. This is the way we can implement this one. Okay, so let's come to the implementation. Which one you prefer? So will I continue with this, or we will go for implementation? I think it is better to continue with the NOR also, then I will go for the implementation. Okay, now for the NOR case, it's better I will continue with this. Okay, then I will come to the implementation part. Now in case of NOR gate, this is the shorted also, the two inputs are getting shorted also. So in this case we are having, so if you are giving X here, so this X is going to both the pins, right? And if the pins are there, so this X plus, you have this X plus X whole bar, so X plus X will give you X bar. Okay, so if you are giving 0, you will be getting 1. If you are giving 1, you will be getting 0. So this is the way actually we are implementing the circuits. Okay, now the second phase, you also please note it down that this is the first not using NOR. Okay, second will be OR using NOR. The person who was just asking me that, ma'am, will it be there? So no need to submit for today's Google form assignment, but final assignment which you have to submit in the classroom, there you have to submit all those things. Okay, now for this case, what is the sectional output? The sectional output for this case will be simply, you can do it by yourself, this will be A plus B whole bar, and if you just, what is the output? Physically A plus B whole bar is the input of this, and if you just bar of that will give you the output. So basically you are getting what? You are getting A plus B, right? So you are getting A plus B, right? So you know the truth table of OR gate. So this first case will be 0 and the last 3 cases will be 1. I am not telling anything, or any detailing is not required. You know this one very well. So you know, so when this shorted NOR will be acting as what? It is acting as basically NOT gate. In the last slide also I have discussed this shorted NOR is working as a NOT gate. That's why whatever is the input was this, and again we are doing the NOT, then we are getting this. See, I think you are not listening what I am telling. I am just telling today's Google form that I am going to send. There you have to send the output for only one AND or not using NAND. But the detailing that I am telling you, all the things you have to write in the Google Classroom. And by this weekend I will be sending you the instruction what to do through the Google Classroom only. Okay, so Google Classroom, for each of the section I will be creating one Google Classroom, and the class codes will be provided to all of you, so that the instruction what to write, how to submit, everything will be there in the Google Classroom. And today's session, if you are unable to do all these things, that's why I am telling, please write it down in the white paper, and at least something you scan and upload. Okay, now for the next part, you are implementing AND gate using NOR. So I think you can do it by yourself. Can you tell me, can any of you please send me the snapshot how it is happening? If you are giving X, what is the output of this one? This will be X bar, because shorted NOR is working as NOT. So you are getting X bar here, you are getting Y bar at this sectional output. Okay, so when you are getting X bar and Y bar, so this NOR output is what? So this X bar, then this plus will be there because not of OR. So another input is Y bar, and you have the overall bar, right? So when you are doing like this way, what you are getting at the end, bar is broken into two pieces, so that means x having a bar previously, now it is having another bar. Okay, now the plus is converted into dot, okay, and then y having one bar and then it is having another bar. So you are getting ultimately x dot y, right? So the output you are supposed to get is the truth table of the AND gate. So in this case 0 is 0. So for the first three inputs, you know, the AND will be 0, and the last case when the input will be 1 1, the output is 1. I think the doubts are clear, right? No, I do not know your name. I am repeating once again, the gates only NAND based things you have to do it in today's Google form link. Now that's why I am telling you, please write it down in the copy, right? So otherwise it is very difficult to do it. And this is the last, is the XOR gate. So XOR gate is another thing that you can do it. Okay, now I am just so I am going to the Proteus software. Those who are having the Proteus, they can also open the Proteus, and let's start the experiment one by one. So those who are not having the Proteus, I told you I will just find another choice of doing how to do it, like either Tinkercad software or LT Spice. We need to find it out, like if the lockdown is over, so everything we have to do it in the hardware lab. Okay, so we are actually skeptical about when the college is going to open. So as of now 3rd August is the date, so let's see whether we have to do it again in the hardware or not. Okay, so just bear with my things, because I have some limitations. Okay, everything it's not feasible, because in one computer I have the MATLAB, I have the Xilinx software, I have the OBS Studio and other packet tracer for the, so it is very difficult to install. My system is getting slower and slower, and lastly you have seen that the presentation got stuck in between. Anyways, please bear with the inconveniences, because we are on the same boat, right? So I am doing the NAND based operation. Okay, so I am doing the NAND. I think it is just wait. Just wait for 2 minutes. It's opening, please wait for. Okay, otherwise you can do it, you can start doing in your Proteus software also. It takes time, so just, yes, it opened. So that is the problem actually we find when you are doing too many things. You have used model sim, you have used Jupyter, I have also Jupyter, so the system becomes slower and slower. Okay, now the first page has opened, so this is the first thing we need to write the project title. Okay, so whatever you can write down experiment number 2, so you can write down experiment number 2. okay, even if I have done this one earlier, that's why I have given the snapshots also. So we will click next, then next, then next, then next, then we will write finish. Okay, okay, now I think the panel has been opened for you all. Now, so for NOT gate, I am just going to the PPT, and I am just which circuit I need to implement. The first one is NAND base, so this circuit I need to implement. This is right. So if I need to implement this circuit, I need to use the 4011 NAND gate IC. Okay, now I am going to the Proteus again. In the P, please click P stands for the PIC device panel, and if you click P, what you are supposed to get, you will get a blank right this way. Those who have already done, they know this one. Those who are doing newly and install the software newly, please have this one. Okay, so which gate I will be using? 4011. Okay, so you click the first one and then click OK. Right, so this is the way you can just have this. You can see that 4011 is there, right? So now just click once here 4011 and you just click it here. Double click here and place it. Okay, now the size is very small. Okay, so in the last class what I told you to just maximize the screen, we should use this plus sign to maximize the screen. Okay, to maximize the screen we should use the plus sign. Okay, now in this case what we can see here is that you can see the green panel. You can see in the left hand side, you can just move this one around so that you place this position properly, right? Otherwise it is very difficult to trace the elements where you are putting. Okay, now for this case I have put this one. So what are the things I need to incorporate? We need to incorporate the inputs as well as we need to incorporate the outputs also. So for input, which we will use two things I told you, please note it down. One is logic state, please note it down, logic state. Another is logic probe. Logic state is for input and logic probe is for output. Okay, so I am just telling you, you write it down. I think it is visible, right? Logic state, LOGICSTATE, logic state without any space. Okay, so I have done one area, double S is there. Okay, so logic state is there, so you just click it here and just click OK. So you can see logic state has been there. Okay, now next thing I have to add the, you can do it simultaneously. Okay, you just have the video and do it also. Click the PIC device again and write logic probe, PROBE, logic probe. So you click the first one and then you click OK. Right, so this is the way we have done. Now, so what are the two inputs I require? How many inputs are required? For NOT gate I require one input, right? But for other gates I will be requiring two inputs. Okay, now for this case I will be using the logic state here, one input. I am just placing it here, and for the logic probe I am just placing the output here. Okay, this is the way. Now what I have to do, shorted NAND is working as a NOT gate. So what you have to do, you have to short the in breadboard. When you will be doing the hardware lab also, you can see the breadboard connection, like there are upper strip and lower strip, and in between two strips are there, right? So for the upper strip and lower strip we use the for power connections, like plus 5 volts a VCC we use, and for the lower strip we use for the ground connection, and in between we put the ICs in between and we do the circuitry connections. Okay, now for this case we, in the hardware also, we need to short the two pins by a small wire. Here wire means this type of connections we are doing, and then we are connecting this one with this. Okay, this is the way we are doing all these things. Now output you connect it here. Okay, now you just go to the debug section. Is it clear to you? I think it is clear to you. So I have done the input. Sorry, if something happens like this way, it is unwanted, then you please give the escape. Please press the escape, then this pink color things will be gone. Okay, so the thing is that when you are going to simulate this one, you have to go to the debug section. The circuit is drawn. I will just tell other circuits also one by one. So no need to worry at all that I am not doing the simplest one. I will be doing the complicated ones also. So go to the debug section, start SVM debugging. Go to the debug section, start SVM debugging and click it. Okay, now then you go to the debug again, okay, and run the simulation. Okay, many times it happens that it is not working. So what we have to do, actually we have to just remove the circuits, and by selecting and just deleting the components, it happens. Okay, the software is not, nothing is perfect in this world, right? So many times it happens. So if I now just, what you are supposed to get, actually I have kept this type of blank sheet again, and I have just made the blank truth table. So you are supposed to, 0 and 1 are the two inputs, and what you are going to get, that I will show you. Let's see what happens. So if you are giving 0, what you are getting? You are getting 1. Okay, now if it is getting 1, I think there is no hazy thing, right? Okay, if you are, somebody texted me that if you are clicking P and it's showing no library found, I think your installation error is there. Okay, there are YouTube videos, you please go through the video. I will send you the link also, how to remove this type of error, please, after the class. Okay, please bear with that. Okay, now so let's check. So if you are giving 0, you are getting 1. So I will give 0, so you are getting, you can write it here also. So instead of 0, we are getting 1. Okay, and if you are giving 1, you are getting 0. So I think there is no problem in observing this one. So if you are giving 1, you are getting 0. If you are giving 0, you are getting 1. So it is there is no simulation problem for this case. Let's see for the other cases, because we have to go a long run. Okay, so let's go for this. The first circuit is done. So I think those who are doing, they can take the snapshot and they can also paste it in the Word. Okay, so your, it's no need to have some extra time for do, and that keep all the keep all those things saved in the file section, and you can reopen the file also. In the last class also I have shown you, please, in my case the files are stored in documents. Okay, so in your class please check where the files are getting stored. So every circuitry, where whatever you are doing, those all the things will be stored. It's not like that everything you are doing it, but you have to find out the location where the files are getting stored. Okay, now the thing is that the first is over, right? So the circuit, this circuit is done. Now go to the second one. Please draw it in your copy, otherwise every time when we will be doing, we will forget about. So how many ICs you will be requiring? You will be requiring actually one IC, and within that how many gates you will be requiring? You will be requiring 3 NAND gates, right? So 3 NAND gates you will be requiring. So let's go to the Proteus. Okay, so I will place 3 NAND gates and I will connect just first to shorted, and next the output of this two will go to the third one. Let's see what happens in case of Proteus. Okay, so I am just keeping this one aside. So I am just scrolling the green bar a bit so that I just have this open view, right? So you can just, you have this section, but I do not want to view it, so I want to view this one. Okay, just wait, somebody has sent me the problem. Please debug this one. Okay, you are not, I think Oyon has sent me the problem. Please do the start debugging, then run simulation, otherwise you will not, the system will not run and you will not get the proper output. I am showing the next experiment also. Okay, now see this one. What I have done the debug section, start SVM, then start simulation I have done, then that's why the proper thing, proper output came, right? Otherwise you will not get the proper output. Okay, now the second one, just wait, just let me fix this one. Okay, Second one, how many NAND gates I require? I require basically three NAND gates. Okay, so let's place like this way. I will be using one NAND gate. Okay, I have done the you see one thing. Suppose the simulation is running. Okay, I cannot place the NAND gate here. I tried, you can see the real time simulation is in process. Okay, so this type of problem if you are facing, you have to first stop debugging first, then you can go for the second circuit. Okay, now I am putting the first NAND gate. I am no need to click multiple times. You just click one times and then you click again one times. You place it in this fashion. Very good. Some of you may send me the photos and snapshots. Very good. It's done. So we will be doing the things, right? Otherwise very difficult to practical things are different from the theoretical ones. Okay, so we will be learning by doing. Okay, another NAND gate I require. Okay, I am just placing the NAND gates. Now see what happened, how many gates, which gate you are going to implement, OR gate you are going to implement. So definitely two inputs are required, right? Two inputs are required. Now in this case what will happen, these two inputs, for that you require two logic state you require and one logic probe you will be requiring. Okay, so for this case I will be, for the NOT gate I required one logic. Okay, those who are having the problem of no library found, that means installation problem is there. So I will send some of the links through which you can just use and you can just uninstall the system and you can reinstall the system. Okay, because the system, the thing we are doing in one system may not be applicable to other system. That is the problem. Otherwise we will go for any other secondary software. Those who are not having the Proteus, I will just suggest, just give me 1 week of time. Otherwise I have to talk to others so that it will be better for you which software is compatible and having lots of ICs. Okay, LT Spice and Tinkercad I have suggested you. If you are happy with that, then you can go for that also. Okay, I can take one doubt clearing session so that it will not be difficult for the others who are not having the Proteus. Now so the two inputs, I want to make this OR operation. Okay, so the two inputs, A I have given and another B I have given. Okay, now what I have to do in this case, what the snapshot suggests, that you have to short it, right? Two shorting is there. So what we will do, we are going to short the two inputs. We are going to short the two inputs. Okay, now after shorting, what you are doing, you are just connecting the input to 5 and 6, another input you are doing like this way. It's not over. Okay, it's not over. Now the output 4 you are connecting to pin number 12 and this output you are connecting to this. Okay, so if it is happening like this way, it's not connected, please give the escape. Okay, now you connect this one to, I will come to your query one by one. Please let me complete the circuit, then I will just see all the queries one by one. Okay, so this is happening. Okay, so if it is happening like this, you can do Control Z also. So if this circuit is not working, it may happen if the circuit is not working, I have to select that one. Suppose this is not working. Okay, so I have to select that one and I have to right click that one and I have to delete the object. You can delete the object also. I will come to all of your query. Please let me complete this one. Okay, okay, so I am connecting the probe and you see, if you connect this one, so what is the circuit? This is the circuit for OR gate. Now what I have to do, I will go for debug section. I will use the start SVM. Okay, now for the start SVM it's not clear, then I have to again run simulation. Not only start SVM, with start SVM, start simulation is all, run simulation is also required. Both the things you have to first to go for the start SVM, then run simulation. Now let's check whether it is working as OR gate or not. Okay, now you have this second, so you obtain this NOT gate, right? 0. So I will go for the table of OR gate. I am just minimizing the circuit a bit. Okay. Because I have to write it also, okay, and I have to see the output also. So this is the OR gate. So for all the cases, the first case the output is supposed to be 0. Let's check the 0 0, you have 0. So first done. 0 1, the output should be 1. So it is done. We will write it in the word. So 1. 0 1, you are getting 1. Now for the next one, 1 0, you are again getting 1. So or third combination, you are also getting 1. Okay. And the last one, 1 1, you are again getting 1. So for the last 3 combinations except 0 0, all the cases you are getting 1. So you are getting the proper truth table of OR gate. So no doubt about thing, right? So you are getting all these things, no problem. So this part is very easy, right? Now, so two circuits are done. I am just minimizing it to see whether the things are there. Yes, NOT gate is also there and this is also there. So what I have to do, I have to go for the next experiment. What is the next gate? What is the next gate that I have to do? I have to go do the AND gate using NAND. Okay. Now I just use the stop SVM, otherwise I cannot drag and drop the components. Okay. For the next experiment, the next circuit, I need to use the I have to give the gates, right? So otherwise it is very difficult to do all these things. Okay. Just check some queries. Please wait. Ma'am, it's showing so library. So I told you what is the probable solution for this. And so this is, please mention your name. Your correct answer is correct. Whose number is 82501755599. Your answer is correct, right? Okay. Another query, ma'am, directly upload the Proteus file. You can directly upload the Proteus file, but I have to download and again I have to run the simulations. Okay, so it's better if you have snapshot, you have the snapshot. Assignment page in Telegram. Assignment page I am not giving. The assignment page that you need to submit, you will get it in Telegram. Okay, and the Google form link is also, today's Google form link is also there in Telegram itself. Okay, no need to worry at all. Yes, very good. I do not know your name. It's very good. Okay, so lots of things are coming. Please mention your name, otherwise it is very difficult to understand. Okay, yes, fine. Okay, so let's come. I am just stop debugging this one. Let's go for the last one. So I will be doing the AND gate, right? I will come to the query section a bit later. Let me complete this one. Okay, so in this case, what is the next circuit diagram is this one. Okay, this is the simplest one. You require basically two gates, right? Very good. Lots of people have done very good. All of you have done, mostly you have done. I am very excited that you people are really doing this one. Okay, the link I have not activated till now, the Google form link. Please wait for 10 minutes. I will just do it afterwards. Okay, Debanjan Shaha, yes, your circuit connection is perfect. So Ritam Chatterjee, Proteus is not working. I think you need to do some extra thing. I think your panel is not working. Why the green colors are coming, I do not understand. I will just let you know, please, after the class. Okay, please ping me. Okay, now just go to this this part, right? So you require two NAND gate. Now we will be using two NAND gate. Okay, so I have stopped the simulation part and I have used this one. So I will be using two NAND gate, right? For which, to implement AND using NAND, I will be requiring 2 NAND gates. Okay. Now what I have to do, I will be using 2 inputs also. So I will go to the logic state and I will just give one input here and another input here. Okay. And you can see this one input will go to here directly and another input will go to here directly. Okay. And now you short these 2 inputs. Okay. And you just connect it to it. Okay. So I'm just maximizing a bit and I'm just keeping the cursor so that it is visible to you. Okay. And you have the probe here and you connect the probe here. Okay. Now you connect it with the VATs, right? I think this is the AND gate implementation using the NAND gate. Many of you are sending the screenshots, is very good. Lots of things you have done. It's correct. Thank you for so much interactive. Yes, it's correct. Please send me your name also, otherwise it is very difficult to understand. Okay. Now how will you do that? Go to debug, start SVM. I am doing it again, then you run simulation. Okay. Now you have the word file. I am just opening the word file for the AND gate. So what you are supposed to get for the first 3 cases, zeros are one of the inputs, or both the cases they are the inputs. Okay. So for those cases, what is happening, you are getting the output as 0, and for the last case you are supposed to get the output as 1. So let's check whether it is happening or not. You please give the inputs accordingly. Okay, one thing I am doing, just I am opening the Google form. Okay, that is otherwise it is difficult for you to upload, because last day it happened. I am just opening the responses, so you can at least somehow whatever you have done you can upload it, because the circuit simulation part you have to take the snapshot and you need to upload all these things. Okay. Shulakna, Dev, Orijit, all the things I will check one by one. Yes, Shulakna, Datta Chaudhary, it is correct. Orijit, I think, yes, it is correct. Please send me the things so that I can, yes, Amit Kumar Maji, it's correct. I will check others also. Yeah, license error, those who are coming, for those, please have a check on that, the proper installation part. Shayon, it's correct. So lots of other messages are there, so please just bear with me. I will come to the session. Okay. Now the final one is remaining, right? The XOR part is remaining. So in this Proteus part, I think 0 is 0, 0 1 or 1 0. If you pair all the cases will give you 0, 1 0, or 0 1 will give you 0, only 1 1 will give you 1. So AND gate it is working, so I can write it here. For the first 3 cases it is becoming 0 0 and 0, and last it is 1. Okay, it is fine, right? So I am just coming out of the stop SVM. Yes, Priyanka, it's all right, fine. I think you people are trying. That I am privileged that at least some of you are trying. I am sorry for those who are not able to do that one due to some issues. I will try to resolve it at any cost by this week. Okay. Now, so the simulation part is over. Now, come to the last part, that is the XOR. You have to implement this XOR, right? So how we are going to implement this one? So you have to, just wait for 2 minutes, don't send me messages now. I will be telling you, I will be sending you the PDFs, no need to worry. Okay. Priyanka, it's fine, it's working. Yes, Priyanka, it's fine, and I will send you the PDF, not by today, and all these things. All the PDFs and words, all the things I will be providing you. Now see this one, for in case of Proteus I am just changing the screen a little bit, or you can just delete all these things. I do not want to delete actually, so if you want I can delete it, or I can minimize this one also. Okay. So actually you can see the blue screen, right? You can see the blue pointer, right? So the border line is there. I'm just minimizing this one. You can see the border line. Try to focus, try to implement the circuit within the border line itself. Okay. Now one thing I'm just telling you, I'm not giving this one. I will give a separate file if you want, along with the material also. Now if I want to delete something, what you have to do, I'm just this one. Suppose I want to delete all the things. Okay, so how will you do it? You go to this click, just this is a new thing, please just see this one carefully. Okay, you go to this thing, just selection mode. Okay, you select all these things and you can delete it. Okay, press del. I have selected, go to the selection mode, select all these things and press delete. Whatever I have done, I have deleted. Okay, and selection mode, this, go to this mode and okay. Now again I am drawing the XOR operation. Okay, so XOR operation, what I have to do as per the slide is concerned, how many gates I have to incorporate? I have to incorporate 4 gates. So one IC is required of 4011. So in this case I will be just having this same type of configuration. The way this I am placing one, the upper one I am placing one, the lower one I am placing one, and the right side I am placing one. The way we obtain the figure. Okay, yes, very good. I want to know your name. Excellent. Please send your names also, otherwise it is very difficult. Yeah, I am doing for 3-1 and you have done all the rest. Very good, very good. So just have a note on this. So how will you connect this one? How many inputs are required? I require basically 2 inputs. I require A, I require B. Okay. Now what we are going here, we are connecting A with this, and we are connecting B with this one. Okay, I think it is understandable. Okay, then what the rest I am doing, I am just connecting this A with this also, and I am just connecting this B with this also. This is the first stage. Now output of this will go to this one as well as will go to this one. Okay, and then what you are going to do, this output will go to, I will come to the messages, please wait for some time. Akash, please wait. So this one, I think the circuit is okay, right? And you have this probe as the output. I am putting this one here and you please connect it here. Okay, so the circuit connection is done. So 2 inputs, AB and this. You go to the debug section, start SVM, and then go for the debug and again run simulation. So in case of XOR, what happens if 2 inputs are same? If 2 inputs are same, the output is going to be 1. Is it so? I think not. If 2 inputs are same, the output is going to be 0. If 2 inputs are different, then output is going to be 1, right? So the middle 2 rows will give you a 1 output and the first and the last row will give you 0 outputs. Okay, so let's see what happens here. Because every time I am doing in normal mode and in the class it happens something gets erroneous. Okay, because it's a run time. So we have this debug and this stop simulation I am doing, this start simulation we can do, and then we have the run simulation. Okay, so 0 0 will give you 0, and let's check 1 1 is giving you 0 or not. It's not showing. I think some error is there. And how can you find the errors? Can you tell me how will you find the errors? There are errors. How will you find the errors? Actually, when you are doing this, symbols are not coming. That is the point I am like to say. You see, when your simulation is correctly, you can see it's not running. Why? This point is a question mark. Even if in the runtime you are giving 1 1, it is giving question mark. Okay. So what you have to do? You have to delete all these things one by one, and then again you need to simulate. So before, after compilation, please check whether this all the lights are glowing. Is it gray? That means this part is not working. This connection is faulty. You have the faulty. I have done some faulty connection. That's why this is not working. Okay. So what you have to do? You have to just delete all these things again. You select this one, and then you select this one, and you delete all these things. Okay. So you cannot delete now. You have to again stop simulation, and then you can delete it. Okay. So I have though another thing to check, because I have done this one previously. I think I'm just opening this one. Let's see. This is another Proteus I have done before the session. So let's check. It will take 2 minutes to open this one. It sometimes happen due to this. See here, it ran and there was no problem as such. I have not faced any issues. Okay. So it depends, because it depends where you are doing. So you have the connection here. Yeah, for you it's working, but for me it's not working now due to some connection. So where connection problem, so I have to check one by one in a little bit of slower fashion, so that we can get it. Okay. Now I go to this one. For this case it happened. Okay. So for 0 1 you got 1, and if you run this one, it is happening. Anyways, so I think you are capable enough to do it by your own. Okay. So try to listen the class, then you can submit all these things. Okay. Now, so this part is also done. Now I am coming to part 2. This is very important. This is very important. Okay. This part is over. So part 2. In the last class I have shown you, I have given you some problem. Okay. So that was my fault. I never thought that this you people are I think can able to do in a first class. So that's my I'm not that much mature that I have the understanding that it's not to be given in the first class. Okay. Now the thing is that many of you still answered the questions. I am lucky that I got the answers from you also. Now 2 things I like to mention: those who have answered and those who have not answered. For both of them I like to tell something. Few answers, when you have been given an equation and you are supposed to draw the circuit diagram and you have to validate the expression, what you have to do? The first part is over. I think part 1 is over, right? The function, all the basic gates you have to implement using NAND. All the basic gates you have to implement using NOR. Those 2 parts are over. The Google form link is it's open already, and the query is based on NAND. The NOR part and all the detailing I will be taking from the classroom point of view. Okay. Now in this case, you see the implementation function. When you are given with a function, you have to find out which is the minimum thing that you have to implement. Okay. Can you do it without C bar? No. So C bar is the first thing, right? So C bar will be done first, then whatever the C bar you are getting, then that you have to multiply with B. So B then is required, and you send the B and C bar through the AND gate, and then you are sending I will be coming to your queries. Please wait for a while, and you send the whatever is the B into C bar. Okay. You just add it with A, so that you will get the final output as A plus B into C bar. Now the thing is that you can implement the circuit in Proteus. Okay, you just take the 3 inputs and you just do the circuit in Proteus. But can you validate the circuit, that whether the outputs are coming, that is proper or not? Can you validate it? That you have to validate. Okay, so for that you have to first go to the truth table part. Okay, so in case of truth table, what can I say, that I will just go through this. So what are the terms present here? You have to get this function. For that you require this b into c bar term. In first year you have already done this one. So I have made one column b into c bar. I have made another column this c bar, because c is directly given, so c bar is required when you are making this one. Okay, in future if you will be matured, so you can directly do it by yourself, but the first class, so I am just telling it a bit elaborately. Now whatever is the c, if you just do the complement of that, you will get c bar, right? So if it is 0 1 0, you have 0 1 0 1 0 1 0 1 like this. So what is going to be the c bar column? Can you solve this one quickly, and can you send me the truth table also? The c bar column will be what? C bar column will be 1 0 1 0 1 0 1 0, right? So c bar column will be 1 0 1 0 1 0. So I can write it here. It will be just opposite. If it is 0, it will be 1. So it will be 1 0. As it is 1, it will be 0. Just the reverse or inversion of c. So it is 1. As it is 1, it is 0. As it is 0, it is 1. As it is 1, it is 0. So 1 and 0. So whatever is the c column, the form is open up to 4 o'clock. After that it will be closed. Okay. Now, so for this part I will not take too much of time. By 3:30 or 3:40 I will try to complete it. Please listen to this also. So for this case, what we will see, that the b into c bar is the column. So b means what? This column, right? So b into c bar, the 0 into 1 will give you 0, right? So this will give you 0. 0 into 0 will give you 0. Then 1 into 1 will give you 1. Then 1 into 0 will give you 0. Then 0 into 1 will give you 0. Then 0 into 0 will give you 0. Then 1 into 1 will give you 1. Then 1 into 0 will give you 0. See, why I am telling this one? I need to validate the truth table with the Proteus one. Okay, validation part is required. Now you see, when we are doing so, last column is what? A plus b into c bar. So we have to multiply the addition of a with b into c bar. So what you are going to get here? You are going to get here, you just add this column with a. Okay, so you are supposed to get the column like this is, right? So it will give you 0, then you will get 0, then you will get 1, then you will get 0, then you will get all 4 ones are there, right? So 1 is added with anything, that will become 1. So for the last 4 things I need not to check what is the value of b into c bar. So I can directly lots of people are sending me the messages, and I think it's correct. Okay, it's correct. Yes, it's correct. It's not correct. Whatever, please see, do it minutely. Okay, it's not and, it's not product. Okay, it's OR operation. So it will be 1 1 1 1. Because a is 1, na, how the last values will become 0. So whether you are getting this or not, please respond here. So 0 0, then 1, then 0, then last 4 ones. Yes. So Debanjan, your answer is correct. Yes, this one answer is correct. So try to match. Yes, correct. Okay. So they are sending the things. Now, can we do the same simulation in Proteus and can we check whether it is coming or not? So whatever the truth table you are getting, I will check that one with Proteus and I will see whether it is happening or not. Okay. Now let's see with the output that I obtained here. Now you can see the first combination that I have obtained. This is the way A, B, C I have taken. For 0, 0, 0, what is the output or what is the proper output? I think for the first two the output is 0. For the first 0, 0, 0 the output is 0 and 0, 0, 1 also the output is 0, right? For the 0, 0, 1 combination the output is also 0. Okay, C you are taking as the rightmost. Okay, C you are taking as the rightmost. C, then B, then A. The upper one is A. Google Classroom will be created and it will be posted in your Google Classroom will be created and it will be posted, right? What are the things you need to submit? Don't need to get worried from the very beginning. Okay, now you see this is the second case. If you see the third one, what you are supposed for 0, 1, 0, what is the output you are getting? For 0, 1, 0 you are getting 1. That is the correct answer. You have the truth table with you, just please match with this. Many of you have done the truth table, please match with this one. Okay, and then for 1, 0, 0 you have this one. Okay, for 1, 0, 1 you have this one. So from 1, 0, 0 onwards, whatever are the four combinations from 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1, you are supposed to get 1 as the output. Okay, you are supposed to get 1 as the output. 1, 1, 0, again you are getting 1 and the last one is 1, 1, 1. You can see from the figure the output is 1. So this is the way actually we are validating. Actually I have taken the snapshot of all the 8 cases from actually if the number of input is 3, so how many number of combinations will be there? The combinations will be 2 to the power 3, right? 2 to the power 3 means 8 number of input combinations will be there. Accordingly I have taken 8 snapshots and pasted here. Okay, now can you do this one? Can you make a circuit to indicate a 3-bit odd and even number? Okay, I will send the file of AND OR based gates and I will also send this file also. Along with the instruction set, along with the documents, I will send this files, that is the running files also, so that you can just download and you can just run in your simulator also. Okay. Now, how will you design a circuit to indicate a 3-bit odd and even number? How will you do it? Suppose instead of normal function, if a function is given, then it's easy, right? So you can just, in the previous case the function was given, but here you see no function is given, so a description is given. So from description, how will you write the function? From description, how will you write the function? You see, if the number is even or odd, here in this table I have created only for even, and if you have the function, if you write the function, then you just pass it through the NOT gate, then you get the function for the odd number, right? So first case, how many inputs are there? There are basically 3 inputs. So when input is number of input is 3, when the number of input is 3, number of rows will be what? Number of rows will be what? 2 to the power 3. Okay, so if there are 4 variables, I just twist the problem, like design a circuit to indicate 4-bit even or odd, then what you are going to do? So in that case, how many inputs will be there? 4 inputs, right? So for the 4 input, how many rows you have to construct for this truth table? This is a truth table you are forming, right? So you are forming the truth table. You are forming the truth table from the description. One problem description is there. You are just forming the truth table from the description. Yes, only you have to submit the PDFs. That is the thing. The snapshots only you have to submit in the Google form. Okay. The snapshots you are sending me, you have to submit the things. Only NAND or only NOR. If you are unable to do it using NOR, you can do it using NAND, right? No problem. So I will edit that one, no problem. At least you do something. NOR part you can later do it. Okay, you upload it first. Whatever is the problem you will be facing, that I will take care of. Okay, no need to worry. So consider this is NAND and you upload it. At least NAND part you are right. You are clear, right? So you have done with the NAND. You upload it and later I will check. Now, so there will be 8 number of combinations. Okay, and you know that one. What is the decimal value of this? Decimal value is 0. So when it is 0, 0, 0, what is the corresponding decimal value? The corresponding decimal value is 0. And one of your friends or many of your friends told me that how to convert this type of binary into decimal quickly. We write like 1, 2, 4 like this, right? So there no 1 is there, right? So it is 0. So for the second case, under 1 this 1 is there. So what is the decimal equivalent? 1. For the third case, this under 2 this 2 is there. So what is the decimal value? 2, right? So for this case, under 2 1 1 is there and under 1 other. So you have to add this 2. So 2 plus 1 will be the corresponding decimal value, that is 3. Okay, you please upload the thing. Okay, whatever you are doing, please try to upload the thing. It is the runtime assignment. Okay, at parallel you cannot listen and do all these things. Whatever you have done, please upload the thing. Okay, the detail of the assignment will be posted in the Google Classroom by the end of this week. No need to worry at all. Okay, and alternation of the other things, that is what are the other types of software that we can use, I will search again and I will just suggest you all. Now for this case, this is the 4th and then it is 5, because this under 4 you have 1 and under 1 you have 1, right? So you have 4 plus 5 and then under 4 you have 1 and under 2. So this will be 4 plus 2 will give you 6, and for this 4 plus 2 plus 1 give you 7. So 0 to 7, 8 combinations will be there. Okay, now whether it is even or not, I am just erasing the, just wait, I am just erasing this links. So which are the things? I am just writing this is 0, this is 1, 2, 3, 4, 5, 6 and 7. What are the even numbers? Can you please tell me quickly? The even number is, right, 0 is considered to be even. So this is 1. 1 is not. So that's why the output we are considering. So those who are the even numbers, I will be keeping the output as 0. That is, the LED will glow. You are making a circuit so that LED will glow, right? So output is 1 means the LED, if you are putting some LED at the end of the thing, the LED will glow, right? Now for 0, 0 is even, 2 is even, 4 is even and 6 is even. All the 4 things are even, right? So 1, 0, then for 2 it is even, that's why I am putting 1. 3 is not even, 4 is even, 5 is not even, 6 is even, 7 is not even, right? Now from this truth table, this suppose the function is f. So if f is the function, can you tell me how to, from truth table, how will you write the functions? From truth table, how we will write the functions? We will write the functions, we will check where ones are there. Okay, just listen very careful carefully. I will be repeating this section in the theory class also. From this description, I have drawn the truth table and I have put the values of ones where it is required. Okay. And second thing, I have used ones for the even numbers. Okay. Now, where the ones are there, I will notice only those corresponding rows. I am repeating once again. Where the ones are there, I will see or I will check only those corresponding rows. Okay. This row I will check. This row I will check. And definitely this row I will check. Okay. Now please see or please listen carefully. Okay. I am just becoming a bit slower. This is very, very important. So if I in the theory class also, if I give a problem, from problem to truth table, from truth table to equation, from problem to truth table, from truth table to equation. What I have told, where the ones are there, here one is there, here one is there, here one is there. I will check the corresponding inputs. For this case, if it is 0, 0, 0, so I will consider the variable is a bar into b bar. I am considering this for the sum of product. Okay. SOP form. You will be hearing these terms later, as this experiment is there in your syllabus. That's why I have to describe this one, right? But I will repeat all those things in your theory class also. So a bar, b bar and c bar. So I am doing the SOP form, that is sum of products. Sum of products. How many products will be there? How many products will be there? There will be, for this one you have a product term, you have product term for this one, you have product term for this one, and you have product term for this one. What will be the product term for this? That I am going to write. So as the input, three of the variables are 0, 0, 0. If 0 is there, I will take the complement of the variable. So I am writing a bar dot, here b is also there, into b bar into c bar. This is one product term I obtained out of this one. Okay. Next, can anyone tell me what is the next term? For the next input combination we have 1. So what is the next product term? A is 0, right? A and C both are zeros, right? So you can say this is a bar into b is not changed, so b, and this will be c bar. So it will be a bar, b, and you have c bar. Is it clear to you? Next, the third term you are again getting 1. What is the input combination for this? 1, 0, 0. 1 means A is remaining unaltered. I will write A. But B and C, you see, B is 0, again C is 0. So what will be the value of B and C? It will be B bar into C bar. So A into B bar. Please bear with my handwriting. B bar into C bar. And last one is 1, 1, 1. This is the 1, 1, 1. So if it is 1, 1, 1, what will be the output expression? Very good. Very good. This will be ABC. Very good. You listen, but please do not forget to upload the file. Okay. You listen carefully, as well as you need to upload the file also. Anyways. So I will not take too much of time. So what I told you, sum of product. So you are doing the sum of certain terms, right? Sum of the product. So this will be one product term, one product term, one product term, one product term. What are the 4 product terms here? These are the 4 product terms. So what can I write it here? This will be A bar. This will be B bar, C bar. The next term is what? This will be A bar, B, C bar.
The next is A, B bar, C bar. Okay, and the last term is A, B, C. Is it clear to you? I think it is clear to you, right? So bear with my handwriting. What I told, I have opened the truth table, I have put where the values should be 1. I am making a circuit for even first, odd I will do it later. For even, I have kept 2, 4, 0, 2, 4, 6 as 1 values, and then I have checked what are the input combination related to this. Then for each input I considered if 0 is there, so one product term will be generated for each input combinations. Got it? And then I have summed up all the 4 product term combination, and then I have created a function. Even if you have doubt, you can just send me. I will check all the messages. I used to try to reply all of your messages as per my capability. Okay, because lots of things are there, so I used to miss some of the messages. So I think this part is over. Okay, now can we implement this function using Proteus? A big function. You can see it's a big function. I have implemented this one. So this type of function you have found out, right? And if you have found out this type of function, what will be the output of odd function? If we pass this function, or if we do the not operation of all these things, what can I say? I can write the full function, and then if I give a full bar over that, I will get the odd function. Okay. Now I have used this Proteus software to implement. I will send this file also in your Telegram official group. So this is a big equation. Okay. Now this is one product, right? This is another product term. This is another product term, and this is another product term. Now you can ask me, ma'am, why you are telling, how you are understanding. You see, in one product term, how many gates are there, AND gates are there? For this product you require one AND gate, and whatever is the output you are passing through AND gate, and you are multiplying with C bar, right? You are multiplying with C bar. So to implement one product term, how many gates are there? 2 gates are there, right? So you require 2 gates to implement this product term. Okay, so that's why I have done one by one. I will just tell you later. So you can implement, you can do it in your further time. If time permits, you just do it later also. So suppose I have just dragged the lines of from this point. So ABC, I have taken this A, B, C and I have taken the inputs and I have just passed this. So this create one product term. You can see 2 NANDs are there, this. Now how many ORs are there? Can we put 3 ORs at a time? You see, how many ORs are there? 1 OR, 2 OR and 3 OR. Can we put all the things at a time? It's not, you have 2 input OR gate, right? So you cannot pass the 3 things through one OR gate, or 4 things through one OR gate. Okay, so what you have to do, you have to pass this product and this product through one OR gate 1. Then you pass this product and this product through one OR gate, and whatever is the output, you pass it through the final OR gate. So actually you require 3 OR gates, but stage wise you will be requiring. So not at the same time you will be requiring. Okay. Now this is the way, and this function is mainly for the basically even function I have done. Okay, I will send you the file because it is difficult to do all the big circuits, and we see that we used to get faults and all these things. So I will send it, and this is another thing, the same circuits I have done. Maybe I have clipped out because the size is very high. So, and if this up to this, it is the even, right? The same thing, this one, and this one was there, and this 3 OR gates were there. And if I pass this final output even through one gate, which gate? NOT gate, right? If we pass this one through NOT gate, what you are supposed to get? You are supposed to get which function after this? Odd function, that is F bar. Okay, is it understandable to you? So it will take time. Suppose I will take a full 1 hour to implement this one accurately. It takes time, right? It is not I will try not to delete this video, but let's see. I will not delete this one for the time being. Now now your question. I have done this one, right? The function I told you, this you can just no need to remember which function ma'am has written. Eta ki hobe? This is basically zeros. A bar means definitely 0, because you are doing the SOP form, right? 0 0 0. Yes, 0 0 0 means A bar, B bar, C bar means 0 0 0 0 means what is the decimal value? 2. This is 0 1 0, right? A bar means 0, B is 1, and then C bar 0. So this is 0 1 0 means this is 2. This is 1 0 0, right? And this is 1 1 0. Sorry. Last is 1 1 0. Okay. Now can we solve this? Can we solve this? Okay, you just submit your files. I will be here. You just submit your files first, otherwise it is very difficult. 15 minutes are left. You have to send the data also. Can we meanwhile you submit? I will not delete the video. Okay, so if we want to solve this one, because what is the requirement of minimization? If you have a function like this much of big function, okay, so how many gates are required? Have you seen? For this you require 2 AND gate, for this 2 AND gate, for this 2 AND gate, this is another 2 AND gate. So how many AND gates? 8 AND gates. You require 8 AND gates. Not even AND gate, you require other gates also. What is the requirement of minimization? I am telling you. Okay, now for this case, please don't call me now, just I am within a class, so I will receive your call after the class is over. Okay, now for this, how many NOT gates are required? You can use 3 NOT gates, and by varying connection you can do it. So NOT gates is not a problem. You only 3 NOT gates are required. You can just tap and use it. But OR gates are required, right? You have required 3 OR gates. Minimum 3 OR gates are required. Now how will you solve? If you solve it, so from that big circuit, can we try to minimize this one? Let's try. So we can use some simplification. The first slide I told you that simplification is required to solve the minimize the function, right? So how can I simplify the things? You can, from this term and this term, you can see that which are the common parameters. A bar C bar is there, right? A bar C bar, here also A bar C bar is there. You can take common, right? I can take use of this, and you can write A bar C bar, you can take common, and within bracket you can write down B plus B bar. Okay, for the first term. Now for the second term, what we can write, which 2 terms you are going to take as common? Many of you are just sending messages. Whatever you have done, try to send it, and proper form of assignment I will be taking through the Google Classroom. Okay, no need to worry at all. Okay, now for the second two terms, this term and this term, what are the things you can take common? AC bar, okay, AC bar you can take common, and what is the remaining part? You have the B bar plus B. So you have done a big circuit diagram for even odd implementation. Okay, now let's see how it is getting minimized. Now for this case, B, I have done one mistake, that is B bar will be there. Okay, now for this case, you know something plus bar of that one will give you what? 1. For this case also, something into bar of that will give you 1. So if you get it like this way, you are getting for this term A bar into C bar into 1. So you will get A bar C bar, and for this case you will get AC bar. Okay, you will get AC bar. Sorry, you will get AC bar. So again, from this case, you can take common of which parameter? You can take common of this C bar term. You see, a big circuit is reduced to a single variable bar. Okay, let's see. A bar into A bar plus A, and this will again give you 1, right? So what you are going to get ultimately? You are going to get C bar. Okay, so ultimately this function, even function, you have this, suppose you have this, we generally draw it in the first year, we used to draw it like A, we have drawn like this, you have drawn like this, like B, you have drawn like this C, and you have drawn like, okay, so the two variables are not at all required. Okay, so whatever is this C, you put a bar here, that will give you even function, and this C itself will give you odd function, because the even F is C bar, right? For this is for even. For odd, F for odd, what can I say here? For odd, what can I say here? For odd, we can say this will be C bar was the function, and you are doing bar of that, that is C. So you can directly take this C, you can tap it. I used to tell it as tap it. Okay, so tap this function C, put it through a NOT gatable. So do you require a big circuit that you have done in the previous slide? Absolutely not. Okay, so that is the thing, you require a very small circuit to implement the even odd number system. Okay, so thank you all for being with me. If I require some modification as far as the teaching learning method is concerned, it is free. It is just, I can say it's a free platform. You can just anytime you can communicate to me, and I have already got some of the text. I will answer one by one. Please give me a few minutes of time to answer. I will answer after 6, okay, because I have some other things to do from 4 to 5:30. So I will answer all the queries one by one after 6. Okay, so thank you all. I will request you to fill up the Google form by 4 only. Okay, so please do not request me to keep the form open. Okay, I have to send the data also. So thank you. I think this mode of teaching is good or bad. Please give me a feedback openly. Okay, thank you. So I am just ending the sessions. I think many of you have not yet given the attendance, so try to submit all these things quickly. Okay. So thank you all. Thank you. I am ending the stream.